So, I'm Blue, or Ren, just finished my broadcast engineering degree at Salford Uni, and I do festivals over summer, and I deal with the other kind of traffic, not network traffic, vehicle traffic. And because of this talk, I've recently started a satellite company, Rawsat, because that's a perfectly sane thing to do on a Sunday morning in a friend's front room. And I'm with you.
Yep. I am a researcher doing my PhD at the Max Planck Institute for Informatics. I run Glauca Digital with Alfie, who some of you may know, and I'm noted for many shenanigans on the internet.
Cool. Quick disclaimer, we're here in a personal capacity and not from any of the companies that we work for or associate with. This is just us. Cool. So, let's get started. Yeah.
You may have got here on a bus, and there is a map that shows you where the bus is. This talk is about how we made the bus appear on this map, and several interesting and sometimes frightening discoveries we made along the way of engineering this solution.
Cool. And you can see it at bus.emf.camp if you haven't already. So what is Iridium anyway? You know, it is an element, but in this case it is the satellite system. There's one there, and it basically means that you can communicate as satellites do, which means that you don't need, there we go, so there it is. So it is about 465 miles above the Earth in orbit, and you can see that it's a bit lower than GPS, yeah, along with other things. So, why was this a problem that needed solving? So we started bike shedding for transport for EMF stuff, and I had tried things in my other job with phones, you know, little Nokia phones, which for a driver is not great. Tried with AirTags, BLE, that kind of thing. That failed as well. And when you're wanting to track something like that, a tractor, you can't really hear a ringtone or hear anyone trying to talk to you on the radio. So we needed a solution that would work anywhere. So, yeah, we tried.
Yeah, we considered a mobile network-based solution. I'm sure you're aware you can buy, like, collars for your dog with a GPS tracker in them that uses the mobile network to tell you when your dog's wandered off. This probably would have worked at EMF, but for other festivals, it's just not something that can work. The network might exist, but it might just fall over. There might be no mobile network at all. You're in a field, so communication is not a given. And even for EMF, there are spots on the drive between here and Ledbury Station where there is no mobile signal, so we'd still be missing data doing it that way. So we had to come up with something where there's definitely signal everywhere, unlike any ground-based communications network.
Cool. So we'd initially ruled out satellite because everybody said it was really, really expensive, which is kind of true. But then we started digging through eBay, as one does. There were some other trackers by a company called Now Research, £750 for 16, which is a good deal, but we didn't have that capital at the time. It's actually purchased for someone else for EMF, so we're using one of those on the buses. So these were ones made by a company called Track24-ish. And they were £70 for 6, which turned out to be 7. And this was a complete shot in the dark. We didn't know if they worked, we didn't know if they booted, we didn't even know if they talked to Iridium. It was a 70 quid gamble that has accidentally turned into an idea.
To give you context on how good of a deal this is, one of these trackers retails for about £1,000, and we got 7 of them for 70 quid.
So, yeah, 3 of the Whisper trackers, 4 of the Echo trackers, 1 with an external antenna set that we can mount on vehicles. We haven't needed that, but it's good to have. So there we go, there's our haul, all looking rather... Oh, we can show them off.
Yep, so these are the Whisper ones. They're the bigger ones with the screen and text messaging. And then there's the Echo ones, which is smaller ones with a belt clip. So these are mostly designed for vehicles, and these are designed for people. So yeah, that's what turned up. Few of the missing antennas, but antennas are easy to get, featuring a lovely view of my flat's floor. Turn them on. They all work amazingly. I was expecting maybe one or two of them to work, but no, they just all work, which I guess is, given the context that they were designed for, it makes sense that they're very robust, but I wasn't really expecting a random find on eBay to just work. The hardware inside is interesting. So there's the Iridium modem, which is just a black box you get from Iridium. Can't do much with that. No one really knows how it works. They're very secretive. But then everything else inside is just a off-the-shelf Bluetooth module, an STM32, some flash and RAM chips, and a GPS module. It's nothing revolutionary, and it maybe runs Windows CE, but I'm not sure. The interface looks like it's Windows CE, but from decompiling the binaries on it, doesn't appear to be Windows, so they might have just stolen the Windows fonts. But it definitely has that. It has the mid-2000s embedded UI vibe.
Cool. And may I draw your attention to that little yellow light? That's important later. So, short burst data.
These work over Iridium short burst data. There's a few different modes of communication over Iridium. You can make a phone call. You could have broadband network access, which is like 700 kilobits a second. But satellites consider narrowband internet access to be about 100 kilobits a second. So even worse than the 1990s and very expensive. But short burst data is basically very over-engineered text messaging, so you can send up to about 3 kilobyte binary blobs over the satellite, and it's all using one channel, so it doesn't use up call capacity and other channels. There's just one channel dedicated to this, and it's brilliant for little, short, infrequent updates. By infrequent, like once every few minutes, not continuous data stream.
Cool. Does anyone want to guess what this costs per gigabyte? You're wrong. Over $1 million a gigabyte. Plus VAT. So, however, this is not necessarily a problem because the messages we are sending are 30 bytes each.
10 to 30 bytes, depending on exactly what's in them. So each message is about 2 pence to send, which is not that unreasonable. My bill for these trackers every month is somewhere between about 40 quid and 100 quid, including VAT. So even though if you do the maths on how much you're actually being charged for this data, it's insane. In the context that they're being used, it's not entirely unreasonable. Other interesting things about short burst data is the modems have no authentication to the network. They just yell data with their IMEI. There's no way to prove that that's its IMEI. The satellite picks it up, sends it to the ground station, and then the ground station figures out, is this IMEI one that's registered and who do we bill it to? So you can use up network capacity without ever paying Iridium just by shouting at satellites and clogging them all up. It's a wonderfully designed system. So, another thing about Iridium is it was designed by Motorola in the 1990s. Motorola had a bit of a thing for GSM there, so Iridium, a lot of it is upside down GSM. You just have a fixed thing on the ground and your base station is moving at 17 kilometers a second in the sky. So, it's GSM with Doppler shift correction. It's bizarre. So to actually get the data from the ground station, there's this protocol called Short Burst Direct IP. Iridium calls this a virtual private network. It's an unencrypted TCP connection, so it's more of a virtual network. They also don't like to tell you how it works. They're quite happy to take your money and you say, oh yeah, please send the data to this server at this port. But then you don't actually know what the hell's going to be received on that port because you haven't signed the right NDA with them. So they'll take your money but not tell you what data they're sending you. I found in at least 4 people's WP uploads folder the documentation which says Iridium confidential, you need an NDA to find this. So well done, Iridium security, your docs are very public. I've turned this into, so the stuff that comes over the TCP port is effectively the raw GSM message, completely unencoded. So this is fun, like, weird bit field, like 13-bit length integers packed into messages, so it's compact over a satellite. Turned this into a little server called Cosmos that just takes in the data from Iridium and turns it into a HTTP post request, so I don't have to go insane every time I want to look at it. There's just this thing in the corner that deals with the weird formats and turns it into something reasonable. So, like, it's got normal things you'd expect from a GSM network, like an IMEI in the header and the call data record, because sending a message is just a phone call, but weird. And message sequence numbers and other things. Like, if you've worked with GSM, these fields will be familiar to you. Another thing the satellites can do, which is a bit neat, is they can figure out where the signal came from to within about 1 to 2 kilometers. So this isn't great for actual tracking things, but if you have no idea what the hell is going on, the satellite will tell you, oh yeah, this signal came from, like, roughly Nottingham or wherever. So that's blanked out because that's someone's house, I realised. I didn't realise that until last night, that the lat and long is just someone's house. But it's a neat thing that the satellites can do based on Doppler shifts to just figure out where the signal came from. And it's relatively accurate. So they work, but we've got a bit of a problem. They're encrypted. So Iridium itself is a completely unencrypted, unauthenticated air interface. Anyone with an SDR can just pick up Iridium data. You don't need anything fancy. Talk to the Munich hackerspace. They've got a load of good tools for this. But that means that in the context that these trackers are used, you need to put a layer of encryption over it. So these arrived with encryption enabled. We didn't know the keys. It uses a military-grade AES-256 encryption and has a lot of interesting decisions on how that's implemented. There is no perfect forward secrecy. You set an AES key, and it's really difficult to change that once it's set. You have to take it back to the computer that set the key to be able to change it to a different key. So if you capture a message from the air interface at any point and then get a hold of the tracker several years later, well done, you can now decrypt those messages you captured 3 years ago. The way I figured this out is I found a very shady APK for the companion app for the Bluetooth module, and the APK sometimes does encryption itself, so decompiling the Java stuff in there got me to this, which was like, okay, now I know how the encryption works, so I can start figuring out how I get rid of the encryption. I will also note that says AES electronic code block, no padding, so wonderful security there. And apparently there's DES in there as well, but I haven't figured out what that bit does yet.
So we then thought we'd get in touch with the manufacturer, Trek24, because their name is on it and all over it, and they didn't actually make the devices. They said, hey, reach out to Nortec Defense and get the commands from them. These are end of life, bye. Emailed them, where they didn't reply, weren't very interested. But if you look at that URL, yes, defending the world, one Jira instance at a time.
This Jira instance had all the firmware blobs, all the manuals, all the Windows utilities that go with it, completely unauthenticated for anyone to see. This is exactly what I needed. So then I had to figure out how to actually turn off the encryption. So now that I had a firmware dump, I could start throwing it through Binary Ninja and figuring out how the commands work. This is a wonderfully janky setup took a while to figure out the pin out of the JTAG connector on it, but eventually got there. It was standard STM32, so GDB was quite happy to let me poke around inside. I had found in the firmware dump where it stores its data, just tried to read that out, set it to something. They did at least try to do security because it said memory protected. Okay, fine, I can't read this out over JTAG. So then I was like, what's this like encryption utility on their website? So this thing is a standard .NET application, so really easy to decompile, and I could figure out what commands it was trying to send to the device. Turns out to set the keys on it, you need a crypto officer password. This is fixed length, 8 characters, all lowercase only. It will not let you set it to anything other than that. So, unfortunately, it does actually try and lock you out if you type it in too many times, but you can just pull the power, and that lets you try again. I didn't brute force it that way. Instead, I tried to read out where that password was stored in memory. Again, memory protected. Then I realized I can just single step through string compare and check what it was expecting the password to be against what I was putting in until I'd figured out the password. This took about 10 minutes. And then I could just delete the encryption keys and thankfully be rid of long-term government secrets.
Dare I say, this password was frighteningly easy and may or may not be printed on the unit.
It was not password 1 exclamation mark, but similar vibes.
Yes, it was not great.
So then send this magic command of AT plus AES enable equals 0 with the password, and magically the encryption goes away. There are also some other interesting commands in there which I haven't figured out, such as AT plus AES padding equals 0. I don't want to know what that does, but it sounds bad.
Cool.
So now, on the left-hand side is the data I was getting before disabling encryption, and garbage. It's random data. After disabling encryption, that looks like it has a structured format to it at least. There's a bit of a header that looks the same, and then there's some different bits, but it looks like something you might be able to decode. So then more stepping through the code and staring at ARM assembly and figuring out what the hell the program was trying to do here, because it's not well-written code. And eventually figured out most of it. So latitude, longitude, again blanked out to redact someone's house where we were testing this. Timestamp is just number of seconds since midnight. Velocity kilometers an hour, that's incorrect. It's actually in knots. Because of course they wouldn't use a sensible unit. I was like, is it meters per second? No, that's too low. Kilometers an hour, kind of right. But then I was driving around, was like, no, I'm not. The car is not moving at this kilometers an hour. Oh, it's knots. Okay. Heading is just compass heading. Panic is the big red emergency button on it.
Which we can. Yes, is that this one is on.
That one.
So we can take it. This one is booted up, and you press the big red emergency button. Do not do this on a unit that you don't know where it's come from. We did this on a unit that we didn't know where it came from because we were bored. I mean, we were already poking the right people anyway. If something was going to happen, this would definitely make sure we get their attention. But this is just a Boolean value. Panic, false. Panic, true.
And there are 2 more bits in the message that seem to be Boolean values that I haven't figured out what they are. I think one of them is battery low, but I have not had the time to poke around enough to figure out what these 2 random Booleans do, and they always seem to be false.
So, in our quest to do these, we got these in about January. It's not been entirely plain sailing, and there's been a few other things that we've come across that we have come across or experienced that puts everything into perspective. Now, you've all read these news stories, right? Official documents found in Weatherspoons, official Secrets Act ends up a bus stop. You read it and go, oh, how on earth does that happen? We do a talk at Net Manchester, in Manchester. Go do that if you're in Manchester, second Thursday of every month. But we went out to the pub after. And then we got home the day after. And was like, oh, we're one short.
So, yes, we entirely understand how random USB sticks end up in Weatherspoon's toilets now.
Yes, and trying to explain to the bar staff what this is was certainly an experience.
I think we just got, oh, is it that thing? Yeah, I don't know what it is, but if you say it's yours, you can have it.
Yeah. And then there was one other fun anecdote from EMF, because these have been on the buses, and we've been dealing with the bus drivers diplomatically, because bus drivers
do not always follow instructions.
So we came the other day, we came back, we've only got one tracker. Message queue. Do you know where the tracker is? No. There it is. It's in the depot.
So the neat thing about them being trackers is if you lose them, they tell you where they are. So it was very easy to go find this. And we just phoned the bus company. It was like, yeah, that bus is coming back to you today. Okay, cool. At least we know where the tracker is. And it went walkies. So tracker had an adventure.
So in our quest to do this more, we've had a little bit of commercial interest, which means we've bought more units. I do not wish to disclose what is on those units. It's not good.
It's even worse than the other ones.
It's a lot worse. And as a friend that has something to do with donuts has said, stop buying ex-government shit on eBay. You're making my life hell. So there might be another talk in a few years, or we might just disappear, but come and talk to us. There is another Dymo label on another bag with some very, very distressing acronyms that put it in a time and a place that we really did not want to be associated with, but here we are. It's one where they are actually, if you ignore the slightly scary bit, the hardware itself is really good. It, to a point, just works. And dealing with GTC, the reseller who deals with the airtime, we emailed them, what was it, 10 a.m. Monday?
I emailed them I emailed them at 10 a.m. on Wednesday saying, hi, can we get a few more of these trackers activated by tomorrow? Apologies for being such short notice. And they sent an email back at 8 p.m. saying, sorry for how long this took, they're now activated. I was like, you've done it in 4 hours.
Yeah, and they just do what you think they do. It's kind of refreshing to have a company that you drop them an email and it works.
And yeah, another thing is the invoice is like 40 pages long because the invoice has every single call data record on it. So I asked them, hi, can we have this invoice in like XML or CSV format so it's not such hell to work with? And they said, oh yeah, that's just a flag we can tick. Your next invoice will be in a CSV. Wonderful.
So, yeah, if you want to get in touch, there's our Fedi email, whatever. We have the units, we can pass them around, you can come poke them, come, experience what it was like when we were like, oh my God, what have we got in our hands? Yeah, we'll be at the Q&A tent, and yeah, hopefully we'll have a follow-up in a bit. But, yeah, this has been adventuring in Iridium and putting our foot in stuff that we didn't quite want to.
Thanks for coming.